Welcome back to part 2 of Module 5, Lesson 4, Evaluating Algebraic Expressions. We're starting off this lesson with Example 3, where we're going to take and evaluate some multi-step algebraic expressions. This time they've given us a big old honking problem where we're going to have to use the order of operations that we've learned about in previous chapters. So they want us to take and evaluate 5x minus 4y in parentheses, all divided by z squared, where x is equal to 4, y is equal to 1/2, and z is equal to 3. Just like every other problem we've done, the first thing you're going to do is you're going to write the expression, which they did right here. If you don't start off writing your expression, you will have done the entire thing for fun. I have to be able to look at it and make sure that you're doing what you're supposed to be able to do. So from here, the next thing we're going to do is, of course, going to be substitute in values for our variables. So x was 4, where they had an x, they have a 4 here, so now it's 5 times 4. Y was 1/2, so where they had y, 4 times y is now 4 times 1/2. And of course 3 was z, so you see right here, so where we had z squared, now we have 3 squared. The order of operations tells us to work inside the parentheses first, and inside those parentheses we have some multiplication we have to do. So we're going to take and do 5 times 4, which is 20, and 4 times 1/2, which half of 4 is going to be 2. They went ahead and squared the 3 as well. Personally, I would have preferred if they'd waited on that because it doesn't exactly follow the order of operations, but it does work for this problem. Next, following your order of operations, addition and subtraction inside your parentheses. 20 minus 2, that's going to give us 18. And then 18 divided by 9, well, that's going to end up giving us 2. So you get a final answer of 2, which is what you would end up putting in this box right here. Nothing really complicated, no more complicated than any of the order of operations problems we've done. The only thing different from all of those is now where they had a variable, you got to go bloop and plop in the number that they say that variable's worth. Once again, it's going to be your turn to solve a problem on your own. This time, you're going to plug in the values they gave for A, B, and C into this problem, use your order of operations and solve it, and I'll come back and work it for you in just a moment. Did you do the problem? Did you find the right answer? Let me show you how I did it. I'm going to start off here where I rewrote the problem just like I expect you guys to do. And now everywhere there's an A, I'm going to put a 6. That's going to be right here, so that's going to end up being 4 times 6 minus. Everywhere there's a B, I'm going to need to put a 4. So over here I'm going to have 3 times 4 plus, and on this side it's going to be a 2b, and we're going to close those parentheses. And then everywhere there's a c, we're going to put a 2, so it's going to be plus 2 squared, and we're going to close those parentheses. Now that was a little backwards way of doing it. If it was me actually working the problem, I would have just, every time I got to, I wrote 3, looked up what b is, put a 4, plus 2, looked up what c, looked up what c was, put down a 2, and then worked it that way. From here though, we don't really have a lot of options on how to do it. We're going to use the order of operations where we're going after everything in the parentheses first. That means the first thing I've got to do in those parentheses right there is the exponents. So I'm still going to keep my 3 times 4 plus 2 squared. That's 2 times 2, otherwise known as 4. And then I'm going to divide that by, and I can go ahead and do more inside these parentheses. Oops, I think I put the wrong thing, but for that one, yep, I put a b there when I should have actually put a 4 here. Whoops, thought I had that marker changed. Times 4, there we go. So inside these parentheses, I can go ahead and do 4 times 6 is 24, minus 2 times 4, that's going to be 8. From here, on this side, I can do 3 times 4. That's going to end up giving me 12 plus 4, still in parentheses, divided by, and we can go ahead and finish cleaning up these parentheses. 24 divided by 8, that's going to end up being 3. On this side again, we're going to take and say 12 plus 4, that's going to end up being 16, divided by 3, and at this point, I'm going to take a minute and check my work because that's not looking right. Yes, everything appears to be right here, so keep the problem going. From here we're going to take that 16, put it in the house. 3 goes into 16 5 times. 5 times 3 is 15, with 1 left over, giving us 5 and 1/3, doing your round robin. So the final answer, 5 and 1/3, which we're going to take and come back over here and, Alright, I'm really curious now. Let's see what they have to say about this. They say it's going to be 1. Let me double check my math. You know what? I just found my mistake here. I divided 24 by 8. I should have subtracted 24 and 8. So let me get my marker going here, and we're going to take and clean up all this stupid math that I did over here, and we're going to fix this problem. So 24 minus 8, that will indeed be 16. So now I have 16 divided by 16, which does indeed equal 1, which is the same answer the textbook got. See, even Mr. Reitz makes mistakes sometimes. Our textbook has one more example for us where we're going to use an algebraic expression to find something involving this trapezoid. So let's find out what it is. The expression 1/2 times A times the sum of B and C can be used to find the area of the trapezoid. What is the area of a trapezoid when your A value, that's your distance here, is 9.8, your B value is 12, and your C value is 7? When you're in 7th grade, I'm going to be expecting you all to actually work those with the formula being memorized from the ground up. So we might as well get started experimenting with them now. Start off with, they wrote the formula. After they wrote the formula, what are they going to do? They're going to substitute values in for the variables. A was 9.8, B was 12, and C, that was 7. Now we're going to use our order of the operations. So in the order of operations, 12 plus 7, that became 19. And now you honestly have choices. You could do 1/2 times 9.8, 1/2 times 19, or 9.8 times 19. The textbook decided they were going to do 1/2 of 9.8, which would be 4.5, 4.7 if I did the math right in my head. Let's see here. And I didn't do it right in my head. Pooh. Nope, it's going to be 4.9. Let's try that again. 4.9. Yeah, now I have happy stuff. And from here, you're going to take and multiply that 4.9 times the 19, and that's going to give you 93.1, which you can take and put in that answer if it gives you a warm fuzzy feeling. I'm not going to do that though. Instead, I'm going to take and clear that out, and I'm going to move on to the next thing. And that is going to be extra example number 4, the last problem we're doing in this lesson, where you are going to use the same exact formula and solve the problem with the values they gave you. Go ahead and work on it now. I went ahead and set up my problem. I wrote my formula just like I expect you to do it. I substituted values for my variables, and now I'm going to start working on my order of operations. The 1/2 times 3.25, I'm going to leave alone right now, because instead I'm going to be going after the 3 plus 5.8, and that is going to end up giving me 8.8. Now, if you remember earlier, I said that it didn't matter what you multiplied in here. You got this little thing called the commutative property of multiplication that says order doesn't matter when multiplying. So I could do 1/2 of 3.25, I could do 1/2 of 8.8, or I could do 3.25 times 8.8. And the easiest thing to do is 1/2 of 8.8, because if I did that, I would leave my 3.25 alone, and half of 8.8, well, that's just going to be 4.4. And that made the math pretty darn simple there, didn't it? So from here, I'm going to go off to the side and do my grunt work. Yes, I expect you to do your grunt work on this. This is not a calculator problem. 4 times 5 is 20. 4 times 2 is 8, plus a 2 from the 20 gives us 10. 4 times 3 is 12, plus a 1 from the 10 gives us 13. And it's going to be the same thing again. So I'll get a 0, 0, 3, 1 again, because we're multiplying 4 times everything up there. When I add that up, 0, 0, 3, 4, 1. And then we're going to bounce 1, 2, 3, 1, 2, 3. So the area is going to equal to 14.3, and in this case we're dealing with meters for your final answer. Jump back over here to our problem, and we're going to do, that's not the one I was looking for, there it is, 14.3. I hope if I highlighted it, 14.3. Check our answer. The answer checks. That's it for this lesson. Get started on your homework assignments. Make sure you give me good quality supporting work just like I've been giving you, and make sure you're writing down the problem first. Don't just dive in with a bunch of numbers without a problem to back it up. I'll see you all tomorrow.